Okay, welcome to another Orbiter 2010 video. And in this video, I'm going to be starting a new series. And in this series, we're going to be going to Venus. We're actually going to do a round trip. Going to go to Venus and come back to the Earth. And the reason I chose Venus is because I have 2 videos now, I believe, for going from the Earth to Mars. I've got several videos on going from the Earth to the Moon and back to the Earth. I've got a couple videos going from Mars to one of the moons of Jupiter and Mars to one of the moons of Saturn. And then earlier this year, I did the whole grand tour of the outer planets. But I don't have any videos of the inner planets of Venus and Mercury. And those planets present some interesting, and by interesting I mean difficult challenges. Venus isn't too hard actually, but Mercury can be quite difficult unless you throw all sense of reality out the window and just use unlimited fuel or something. But for starters, we're going to go to Venus. And my plan is to do a slingshot from Venus back to Earth, because realistically we can't land on Venus. Venus is like an oven. It's like a pressure cooker. The surface temperature of Venus is actually so high that the XR2, you get hull temperature warnings all the way into the red. So basically, just trying to land the XR2 on Venus is pretty unrealistic, because the planet is just so hot that the vessel would melt essentially just by sitting on the ground, let alone, trying to do any kind of, realistic landing of any kind. So we're not going to land. We're just going to go to Venus, sling around the planet, and come right back to Earth. The first thing we need to do is find a good date that we can use to go to Venus. And it's really easy to use Transx, but every time I make a video, I kind of like to try to mix things up a little bit and show some different tools or different methods, different things that we can do, so that we're not just constantly doing the same thing over and over. What I have here is the trajectory planner, and this can be downloaded from Orbit Hangar, and I'll be sure to put a link to it in the description of the video. This is actually pretty easy to use once you learn a couple of basic things. It's not real intuitive at first, but it's not hard to use. What we're going to do is we're going to start off by selecting our elements, and our departure element is going to be Earth, and our arrival element is going to be Venus. So here it defaults to Mars, and hopefully this shows up well in the video playback. I don't have any way to zoom in on this really that I know of, so hopefully you can watch this full screen at 1920 by 1080 so that you can see the text, because the text isn't very large. But anyway, we're going to select the arrival element here of Venus. Now, one thing Trajectory Planner can't do is it cannot figure out slings for you. But in this particular case, that's actually okay. I wish it could, but it can't. So we're just going to find the time to go to Venus, and then we'll have to figure out how to do the sling on our own. Now, my prerequisite for this flight is that I want to go to Venus at some point in the future. I don't want to pick a past date. So I'm recording this video Saturday, April 27th, 2013. God only knows when it'll actually be uploaded to my YouTube channel, but that's when I'm recording the video. So I'm going to bring up Orbiter's date converter, and by default it picks today's date, which is again, April 27th, 2013. and it gives me the MJD here, which is 56409. So I'm going to use that as my minimum date for launch. In other words, I don't want to launch any sooner than today. So I'm going to copy that date, and I'm going to put that here in the launch date minimum. So we're just going to highlight all that and then Control V. And then for the launch date maximum, we're just going to add 400 days to that number. So 56409, we're going to call it 56809. So we've given ourselves a 400-day launch window. We want to launch no sooner than today, and we have to have some kind of upper limit just because this is a fairly CPU intensive process, so we can't just have it calculate out to infinity. We have to give it a hard limit, and something like 400 days or 500 days is pretty good. And that's basically it. Actually, I'm sorry, we also have to put in dates for the arrival, and I'm just going to use the same dates. We don't want to arrive any sooner than today, and we don't want to have a maximum arrival date, like that. And technically, putting in a date that's at least like 100 days out in the future ahead of your minimums would probably make more sense, but this will be fine. So we're done with the date converter. We don't need that anymore, but let's look again at what we've done. We've selected the departure element of Earth and the arrival element of Venus. That's, step 1. That's step 2. And then we've got a minimum launch date of today. So think of that as step 3. And then step 4 is the maximum launch date. We just added 400 days to that number. And then we put in, the minimum arrival dates. So those are the steps. Once we've done that, we hit compute. And we can close out the date converter. Take a sip of water while that's computing. And what this program is doing is it's actually going through our criteria, and it's finding every possible solution that exists for going from Earth to Venus between these dates that we gave it. So it's pretty miraculous, really, what it's actually doing here, if you think about it. Now, what we come up with is this weird-looking, graph, with this big mess of colors that, at first glance, means absolutely nothing. And when I first looked at it, it didn't mean anything to me either. But what we're looking at here is this colored area represents the possible launch times for going to Venus. And all of this black area are dates and times that would not work. If we just mouse anywhere inside of this box and click it, you can see that it populates the trajectory elements. And just by clicking here in this black area, it says that launch date would be 56504. But we know, since this is all black, that doesn't work, 56504. And if we want to know what day that is, we can bring up our date converter and we can type in 56504. And that's July 31st, 2013. According to the trajectory planner, this launch date, based on this criteria with this amount of prograde and this amount of outward and this amount of plane change, this is an invalid solution, and that's why it's black. And the farther we go to the right, the higher up we go in the date. So if I click here, now I have a launch date of 56603. So if I want to see when that is, I can type that in over here, and that's November the 7th, 2013. And it's the trajectory planner is telling me that on that date, if I were to use this much prograde, this much outward, and this much plane change, I would not have a solution for Venus. All the possible solutions that exist for going to Venus are in this colored area. So if I want to find one that actually works for going to Venus, then I need to click somewhere inside of this colored area. In the ideal time is this chunk here. I think this is actually called a pork chop plot. I think that's if you do a Google search for pork chop plot, you'll kind of see something that looks like this, and I guess they call it that because it kind of looks like a pork chop, I guess. But this area in here is what Trajectory Planner thinks is kind of the ideal time. So if we click, like dead center, then it tells us 56599. So if we put that number in, 56599, that is November the 3rd, 2013. So that date works, but it's important to note, that that's the same date that we would have if we clicked down here. But the difference is, up here, this is saying that if we use this much prograde, this much outward, and that much plane change, then we'll get to Venus on that date. But if we click down here in the black area, which will be really close to the same date, because again, the dates are left to right. So if we just come down here and click, we should have 56, yeah, I got it exactly, 56599. So we're still on the exact same date, but this whole area here is black. So this solution here for that prograde, that outward, and that plane change wouldn't work for going to Venus on that date. So that's how Trajectory Planner works. If you want to find a solution for going to your target body, then you just have to click on any one of these colored segments. And if you're wondering why is there so many, why are the colors different and why are there so many, it's due to the fact that there are, there's obviously a fairly large range date-wise where you can get to the target. We can come all the way over here to 56426. Let's put that in. That's all the way back to May 14th of 2013, so just a few days from now, 2 weeks from now. According to Trajectory Planner, we can get to Venus on that date, but it's going to have a total departure delta V of 6,301. And the requirement is that much prograde, that much outward, and that much plane change. So that gives us a total departure delta V of 6,301, and that's pretty high. That's about 2,000 meters per second, I think, about 2,000 meters per second more than you would need during a more ideal launch window, which would be up here. See, if we click over here, it tells us that our total delta V, actually I'm looking at these numbers, yeah, the total departure delta V, 2,897, would be up here during this launch window. So that gives you an idea of how to, the basics of how to use Trajectory Planner. I'm not actually going to use I'm not actually going to use a plan from Trajectory Planner for this flight, but I'll use something close to what it gives me. So I did want to show how this works. And if you want to use a plan directly out of Trajectory Planner, once you find a solution that you're happy with, you can kind of click around here until you find exactly what you're looking for. And what you're mainly going to be looking at is your departure delta V and maybe the launch dates, so you're not leaving at a time that you don't want to leave. And once you have that, you can actually click down here for Create Transx Plan and then type in, XR2-01, for example, and then hit OK. And then it actually gives you a TransX plan that's complete. This is with all the stages and everything that you need. So you could then just copy this information out of this text box and paste it right into your scenario file in the appropriate area. That's not a complete scenario. That's just the TransX section. So you'd have to paste it into the TransX section. But this is kind of useful if you wanted to have, a specific way for going about getting over to Venus. If you wanted to have, there might be a reason that you don't want to have the lowest possible departure delta V. Off the top of my head, I can't give an example of what your reasoning would be, but maybe you're doing some sling of some kind and the departure delta V wasn't, for whatever reason, the most important element. So maybe you want to have, a certain inclination or something along those lines. Then using the trajectory planner, you could plan your mission more around your inclination elements or something, as opposed to just strictly looking at, the cost of the departure. So that's the basics of how to use a trajectory planner to find a target date. Okay, so let's go ahead now and exit out of that. And I think what I'm going to do, this is about a 17-minute section so far. What I'm going to do is I'm going to go ahead and end the video here at this part, and I will show the setup of the Earth to Venus using TransX. I'll show that in another video. But if you have any questions about the trajectory planner, go ahead and leave those questions down below. There isn't a whole lot more that I can tell you about it other than what I've showed in this video, because I don't have a lot of experience using it. I've dabbled with it just a little bit to understand the basics. I guess the main thing, again, is just to say is that it cannot be used to figure out slings. So if you want to set up something, Earth to Jupiter to sling over to Saturn, you cannot use it for that purpose. In terms of having it figure out the dates for you for that sling, it doesn't have that multi-body capability. It can only be used, for point A to point B flights. All right, questions down below, and I will see you in the next video. One of the moons of Jupiter and Mars to one of the moons of Saturn. And then earlier this year, I did the whole grand tour of the outer planets. But I don't have any videos of the inner planets of Venus and Mercury. And those planets present some interesting, and by interesting I mean difficult challenges. Venus isn't too hard, actually, but Mercury can be quite difficult unless you throw all sense of reality out the window and just use unlimited fuel or something. But for starters, we're going to go to Venus, and my plan is to do a slingshot from Venus back to Earth, because realistically we can't land on Venus. Venus is like an oven. It's like a pressure cooker. The surface temperature of Venus is actually so high that the XR2, you get hull temperature warnings all the way into the red. So basically, just trying to land the XR2 on Venus is pretty unrealistic, because the planet is just so hot that the vessel would melt, essentially. Okay, welcome to another Orbiter 2010 video. And in this video, I'm going to be starting a new series. And in this series, we're going to be going to Venus. We're actually going to do a round trip. Going to go to Venus and come back to the Earth. And the reason I chose Venus is because I have 2 videos now, I believe, for going from the Earth to Mars. I've got several videos on going from the Earth to the Moon and back to the Earth. I've got a couple videos going from Mars to just by sitting on the ground, let alone, trying to do any kind of, you know, realistic landing of any kind. So we're not going to land. We're just going to go to Venus, sling around the planet, and come right back to Earth. The first thing we need to do is find a good date that we can use to go to Venus. And it's really easy to use Transx, but every time I make a video, I kind of like to try to mix things up a little bit and show some different tools or different methods, different things that we can do so that we're not just constantly doing the same thing over and over. What I have here is the trajectory planner, and this can be downloaded from Orbit Hangar, and I'll be sure to put a link to it in the description of the video. This is actually pretty easy to use once you learn a couple of basic things. It's not real intuitive at first, but it's not hard to use. What we're going to do is we're going to start off by selecting our elements, and our departure element is going to be Earth, and our arrival element is going to be Venus.